All right, welcome. Today we are going on a journey, mapping out the architecture of our connected world. We're going to start right in your pocket and zoom all the way out to cover the entire planet. Let's dive in.
It's something we just do, right? You tap your watch, you send a message, and bam, that data is instantly somewhere else. But have you ever stopped to think about how that actually works? What is the literal path that tiny piece of information takes? Well, that's exactly what we're going to map out today. So first things first, let's bust a common myth. This idea of a single magical cloud where everything lives, it's not really accurate. The internet isn't one big thing. It's actually a series of nested layers. Think of them like Russian dolls of connectivity, where each layer fits inside the next, and each has its own unique scope and its own set of rules. Now, to make sense of this whole hierarchy, we're going to look at each layer through three simple but really powerful lenses. We're talking about its geographical range. How far does the signal actually have to travel? Its data rate, basically how fast is the information moving, and ownership, who actually owns the physical hardware, the cables, and the switches.
Okay, so let's start at the very center of this universe, with you. We're beginning with the smallest, most intimate network there is, the one that literally surrounds you as an individual. This is what we call the Personal Area Network, or PAN for short.
The easiest way to think about a PAN is like your own personal tech bubble. It moves where you move. It's the invisible network that connects the devices you have on you or right at your desk. It's what links your wireless earbuds to your laptop or what sends that heart rate data from your smartwatch to your phone. It's a network that is completely, 100% all about you.
And if you look at the specs, they're super specific. The range is tiny, right? We're talking about 10 meters, maybe 33 feet. And it uses low-power technologies like Bluetooth or NFC. The whole point here isn't to send data across the city. It's designed for pure, short-range convenience. So from our personal bubble, let's zoom out to the next layer. We're going from the scale of a person to the scale of a building, or maybe even a whole cluster of buildings. Welcome to the world of local and campus area networks. So if the PAN is your personal bubble, then a LAN is kind of like your digital home base. It connects every device inside a single building. Think about your house, your school, or the office you work in. This is your Wi-Fi. This is your wired Ethernet connection. And here's the crucial part. You or your company privately own and manage all of it. And the specs here tell a totally different story. The range covers a whole building, and the technology, we're talking Ethernet and Wi-Fi, is all about high-speed, super reliable connections. This is what you need for sharing big files on a server or printing a document that's way down the hall. But what happens when you need to connect multiple buildings? Say, a university campus with a library, a few dorms, and an administration building. Well, that's where a campus area network, or a CAN, comes into play. It's designed to link multiple LANs together with a high-speed backbone, letting them all talk to each other privately without ever having to touch the public internet. So here, the scale just takes another huge leap forward. We're now talking a range of several kilometers, and it's connected by some serious hardware like fiber optic backbones. This is what allows an entire corporate park or a university to act like one single, cohesive digital space. Okay, so we've covered the personal, the building, and the campus. Now it is time to go big. Really big. We're zooming out to the scale of an entire city and then, well, the entire world. So next up is a Metropolitan Area Network, or MAN. This basically takes the idea of a CAN and scales it up to cover a whole city. It connects all the different LANs, government buildings, schools, businesses, all across the metro area. But here's the key difference. The physical infrastructure is almost always owned by an internet service provider, or ISP. The range here becomes truly citywide, sometimes stretching up to 50 kilometers. This is the network that your homeland connects to when you want to get on the broader internet. And that means the ownership has now shifted to being public or leased. You're using infrastructure managed by a much larger provider. And that brings us to the final, outermost layer, the Wide Area Network, or WAN. And folks, this is the big one. A WAN isn't just a network. It's a network of all the other networks. It's what connects all the LANs, CANs, and MANs across different countries, continents, and the entire globe. The internet itself, that's the ultimate WAN. The scale here is just, well, it's planetary. And the technology behind it is mind-boggling. We're talking about massive fiber optic cables running for thousands of miles under the oceans, and satellites orbiting the Earth. This is the global infrastructure that connects billions of devices, and it's literally the backbone of our modern world.
So we've seen all the individual layers, but now for the really cool part. Let's actually trace a single piece of data as it travels through this entire hierarchy, from start to finish. Let's go all the way back to our original question. You tap your smartwatch to check your heart rate, and that bit of data needs to get to a server. Let's say it's in another country. How on earth does it get there? Okay, here's the whole journey. First, your heart rate data travels from your watch to your phone using Bluetooth. That's the PAN. Then, your phone uploads it through your home Wi-Fi router. That's your LAN. From there, it travels through your city's ISP infrastructure. That's the MAN. And finally, it hits the global internet, maybe crossing an ocean on an undersea fiber cable to reach a data center. And that's the WAN. One tap, 4 different networks. Pretty incredible. So when you put it all together like this, you can see these really clear trade-offs at every single level. As the scope gets bigger, moving from your personal PAN all the way to the global WAN, the ownership shifts from private to public. And the latency, that's the time delay, it gets higher. Which makes sense, right? It's why the fastest, most responsive network you will probably ever use is your own private LAN. Understanding this architecture is so important. But what's really fascinating to me is how this entire structure is already starting to change. You see, for decades, these network layers have been very distinct steps on a ladder. But new technologies, especially things like 5G and the Internet of Things, are starting to blur those lines. Imagine a tiny little sensor in a farmer's field, a classic PAN-type device, being able to skip the LAN and the MAN entirely and connect directly to a global network through a satellite. That's the future we're heading towards. And that leaves us with a pretty fascinating question to think about. As this whole architecture of connections starts to evolve, and the smallest devices can speak directly to the globe, what is that going to mean for our data, for our security, and for our whole idea of what a connected world even is? Thanks so much for joining me on this journey.